Welcome to day 13 of competitive programming. Before we start, let's start our timer of 1 hour. I will change to CP directory. Let's open CodeChef and continue solving the questions we have solved yesterday. And we have solved all these questions. Today we'll be solving chunk number. Let's create our file. Okay, let's read the question. Shoykand is good at mathematics. One day, to test his math skills, Kali gave him an integer n. To impress Kali, Shoykand has to convert n into an integer m that can be represented in the form of 2 to the power of x plus 2 to the power of 5, where x and y are non-negative integers, such that in order to do that, he can perform two types of operations: add 1 to n, subtract 1 from n. However, Shoykand is preparing for his exams. Can you help him find the minimum number of operations required to convert n into valid integer m? Okay, they will be giving an integer n. Okay, this question is more kind of based on mathematics rather than more on data structures. So let's read our integer. We'll write our code instead of using snippets. bit/std++ using namespace std and main, and we'll be creating tc variable for test cases, and we'll be call the solve function, which we'll write it shortly. Void solve let's create n and read the n value. Okay, right now they are given an n value. We need to convert it into m. So let's see the test cases. If 10 is given, then 0, because 10 can be represented in the value of 3 and 1. If 22 is given, 2 squared plus 2 power 4, or m is equals to 24 equal to 2 cube plus 2 power 4 in 2 operations. Okay, can we convert it into 3 2 power 0 plus 2 power 1? Okay, actually any number can be represented in the form of these numbers in binary form, which is nothing but binary form, right? But here we can only use 2 digits, not more than 2 digits. Okay, so how can we do this? Still I'm thinking like we'll first convert the given number into the binary form, and then let's check last number into the binary form, and after converting it to binary form, what we'll be doing. We'll see if it is, if we got 1 0 1 1. If we got two ones more than 2, then we will remove the smallest one from it. That's what I'm thinking to do. Okay, first let's convert our given number into the binary. That we'll be doing. So we can, the process is let's say our number is 10, right? So if 10 is given, first we'll divide 10 by 2 and we'll get the remainder as okay, we'll get, if we divide it 10, then we'll get 5. Remainder is 0 and we'll get 5. So remainder is 0. Now we'll divide 5 by 2 and the answer will be, we'll get 2, right? And the remainder will be 1. Next we'll be dividing 2 by 2. We'll get 0. We'll get 1 and the remainder will be 0. After doing 2 by 2 we got 1. If we divide if we divide 1 by 2, the answer will be 0. If you don't believe me, you can see here 1 by 2 is 0.5, and since int it's only integer, we'll get only 0. Like we'll say int 1 by 2. Okay, can we say int x equals to, okay, we'll just float divide it, then we'll get 0. So let's exit from there. So 1 by 2 is 0 and the remainder is also will be 0. Now we need, if we print, okay, once again, if we divide 2 by 2 we'll get 1. Here if we divide, actual remainder will be getting 0, right? 1 0. Here the remainder is 0 and here it is 1, here it is 0. Here actually the remainder is 1 because 1% divided by 2, sorry, 1% divided by 2, the remainder is 1. Okay, that's what I'm thinking actually. So the remainder is 1. Now we need to print this array in reverse order, which will be the binary form 1 0 1 0. So okay, that is the logic actually, but but we will be not printing. We'll take an array to store the numbers. So let's create a function. Well, let's call it as binary. I'm thinking whether we need to have, okay, well, it's void binary is a function. It will take an array as an input. So let's create an array of size, let's take a 32-bit. So a is 32 and it will take that's it, right? An array is enough. Okay, it also need the number in 10. So read the value in 10, the number which we are converting. Okay, and we'll be passing these values when we call them. For now, let's take a variable, let's say I, and the number when it is greater than 0, we go on dividing it and saving that in the array. So a of I equal to n% divided by 2. The remainder we need to divide, and we'll be dividing n by 2. Next we need to increase the index where the I is pointing. That's it. But we need to go it in a reverse order. So you'll get the I value now. Shall we return the I value? So let's say int return I. Let's create a variable called j, and we'll store the I value in it. Okay, now we'll iterate it, or we can just reverse the array, right? We'll swap the last element and the first element, so the array will be reversed. Okay, that would be better because we need not return anything. So void for int j equal to 0, j less than I, j plus plus, j less than or equal to I. Now we need to swap them. So int temp is equals to a of j, and a of j is equals to a of I. Now a of I will take the value of temp. So we are going returning, and we'll be doing it I by 2 times. Now the array has been so will not be doing for the middle term, right? So it will be I by 2. Now the array will be reversed. Now we'll got the binary value. Now for iterate to the we'll iterate right, and we'll count the number of zeros or ones. We'll count the number of ones. If ones are greater than 2, we'll count number of ones. If a of I is equal to 1 plus plus, let's create a variable called 1 and equal it to 0. Now 1 value has been increased, while okay, from the last we need to come, right? So from the last in the self, from the minimum number. So here we need to remove or reverse it, because since we are coming from the reverse direction, we'll be not reversing it. We'll just return the I value and convert it to int and save the y value here. Okay, since starting number is the last number, because we'll be reversing it. Okay, now we'll just start from, okay, 50 minutes are already done. We'll count the number of ones. If ones are greater than 2, then if 1 is less than 2, then we'll just say cout 0. If 1 is greater than 2, right? Okay, less than or equal to 2 will be doing the same thing. Okay, now in the else part, we'll say if we'll remove the elements. Okay, I will say while 1 is equal to 2, what we'll be doing for int I equal to 0, I less than n. Okay, we'll just take a variable called k equal to 0, and we'll say if k equal and okay, we'll also say and k is less than or equal to j, less than j. If k equal to I, if k equal to 1, sorry, if a of k equal to 1, then we'll say 1 now. Minus minus, one minus minus, and answer plus equal to, we need a variable called answer, and every time you remove an element from one position, then you need to do what, in the sense like power. Okay, power function. Shall we write our own power function? I don't. Okay, let's write our own power function. Let's say int power int n and int x. So for int I equal to 0, I less than x, I plus plus, int n equal to int p equal to, okay, just say p equal to n into x. It's not n into x. P equal to n, and n p equal to 1, and we'll return the return p value, and the power will be returned. So plus into power of, we'll add 2 comma, and whatever the power, that is k value. Those many operations will be done to reduce that, and after that the power will be added, one will be increased, one will be decreased, and out of the if statement we need to increase the k value. Okay, and then we need to print the answer. So let's just compile it, exit, clear. If you compile hash include bit slash std c++.h. Okay, we got few warnings. Into main, empty parentheses were disambiguated as a function declaration. Or replace parentheses with braces to value initialize a variable. I don't know what is the mistake I have done here. Function definition is not allowed here before token. And line number 50. Expected at the end of input. Okay, I just forgot to have braces, that's it. Here we'll only print 0, right? We need not have. Okay, now let's compile. We got 0, 0 and 0. 3 of them are 0. It's because okay, to represent 4, it just take 2 power 2, right? So for third case 0, it's sensible. For first case, it's also 0, it is also sensible. But for 22, to represent 22, In binary, the answer will be like 2 power 4 is 16. So it's 1. Then you need 0, 1, 2, 3, 2 power 4, right? Then you need 1, 2, and also 1, 4. Okay, here the number of ones are greater than 2. I guess we have overcomplicated the question, or we are doing the question as they asked us to do. As a human brain does, we are doing in such a way. So that's why it is so long. So I'm thinking whether to remove all this code and to go for a different approach, which is quite easy, or just try to debug this approach. So I'm thinking to go for another approach here. Let's read the question one more time. One more time actually. So they will be giving an n, and we need to go for nearest integer m in the form of 2x plus 2y. We can perform two operations, either add 1 to n, or we can perform subtract 1 from n. So these are the two operations we can do. And the constraint here, he gave the constraint as n is less than or equal to 10 power 9. So we can only perform 10 power 8 operations in 1 second. So we cannot perform this operation in order of n. So we need to perform this operation in order of log n or n log n. Or in constant time. So anyways, our previous approach will give TLA. We are thinking it will give TLA because we have written it in order of n. So to get in order of log n or in n log n, okay, let's say we'll write these values before itself, like predefined itself, like 3, 24, 20, and the numbers which can be represented in 2 power x plus 2 power y. We'll create an array and we will have those values inside, right? So now when you are given a number, we'll search for the nearest number in that array, and we'll see whether we need to subtract or create it. So for searching, we can use binary search, for it is n log n. Now the question is to create these numbers. Since the maximum number is 10 power 9, okay, if in 10 numbers, the numbers which are 2 power which are in power of 2 will be 2 power 0, 2 power 1, 2 power 2, 2 power 3. Those are only like 4 numbers. 0, 1, 2, 4, 8. Those are like 8 numbers. I mean 5 numbers. So that means log of 10 to the base 2 is equals to 5. So log of 10 power 9. 10 power 9 to the base 2. This will give you 30. That's it, right? Log calculator. So log of 10 power 9. Okay, here is power 9 divided by log of 2, because now the log are in e to the base e, so log b to the base a is equals to log b by log a, right? So to get log 10 power 9 to the base 2, we need to do this, and it is 29.89. That means it is 30. That's a pretty good guess. Okay, that means there will be 30 values in the array. So 30 values, 30 into 30 are like 900. We can perform 10 to the power 8 operations, so 900 operations we can perform. So first let's create our int n, and we'll read the n. Next we'll create the array. Also, why not create the array for globally, so that other numbers, let's have 31 here and initialize everything to 0. So for next test cases, we not calculate it one more time, or it doesn't matter, we can calculate it, because we cannot avoid, we can do it for once using do while loop, but it's not necessary. Okay, why not be more optimal? So let's check int I equal to 1. So do, what are we gonna do? Let's take an array of size 30. We need to calculate while I is greater than 1, while I equal to 1, and inside we'll just reduce the I at the end. What are we gonna do? We need to calculate the numbers. So we'll say let's take a vector instead of vector of int and a. So we need to pass a vector, right? So vector of, okay, we'll just pass a. Here we'll be writing vector of int a. Okay, now what we are gonna do is we'll take a for loop starting from 30 and plus plus, and we'll take another for loop 0, j is less than 30, j plus plus, and we'll be like I and j should not be equal, right? If I and j are not equal, then we'll say dot insert or push back, right? Push back, we'll use the power function 2 comma I plus power of 2 comma j. That's it, right? Now we are having our array, and we are also passing that array, and we'll do it only for once, and we'll be calling for all the test cases. We'll be passing that array for all the test cases. Now we'll read the n value. Now we need to search for the n value, right? So to search for the n value, we'll use the lower bound function. So lower bound will give the range of it will return a iterator which will point to the lowest number of the given number. So it returns a pointer, so we need a pointer to vector, so we can say vector int iterator, and let's take iterator it, or you can just say auto instead of saying all that. It's up to your wish. Auto it is equals to a dot lower bound is the function, and we'll pass the n value to it. Now we'll say if, let's say if n is already valid like 3, so we'll say n is equal to, since it is a pointer, we'll take the value of that pointer using the star operator, and we'll print 0. Else we need not do else. Let's say answer is equals to, we'll use answer is equals to minimum of n minus, like we need to if we will subtract it, we need to check for which number it is closer. For the previous number, is it closer, or the for the next number it is closer. So we'll check for previous number of it, and if this is greater, if this is lesser than it value minus n, that means if n is greater means for the lower number, that means we are subtracting here, and here we are it is like adding. So for subtraction and adding, if subtraction is less, then it will say, we will say it is the subtraction value, or we'll just, instead of iterate operator, we'll just use minimum function, because if we use iterate operator, we need to write these two expressions one more time. So we'll say this is the answer, and we'll print the answer, and also the new line. This approach came really easy and also easy to implement. Okay, we still have 27 minutes. Is that it? I guess we need to, here the minimum value of I is 0 and j is 0, so it will be 2. Alright, 2. Okay, they said I and j will not be equal to, that's the reason we have not taken equal, not equal to, I forgot that point. Right here they said non-negative integer such that x not equal to y. So I is 0 and j equal to 1, or j is equals to 0 and I equal to 1 is the case. So minimum value will be 3. So we need to write if n is less than 3, then we'll simply write print 3 minus n values. I mean n is the given number, so we need to add to get to 3, because that is the number present in the array. I will just return from here. Okay, and here also we need to write the return statement, because after printing we okay, or else we'll just say, instead of all these things, so those many return statement, answer is equals to 3 minus n, and even here answer equal to it's not uh, sorry, it's not 3, it's actually if n equal to 0, right? Yeah. And finally we'll also compute the answer here. But we are doing it one more time. I guess we need to have the return statement. If it is written, then we'll not worry. If not, then we'll be calculating it and then we'll be printing the answer. So let's just compile. Vector has no member named, no lower bound. Okay, we cannot use lower bound for vectors. Here they are having a vector of this. Vector contains some numbers. Then they took the iterators. Then they have applied lower bound v dot begin, v dot end. Okay, I guess we need to say low 1. They're saving that value into the low 1. Okay, it is directly giving us the value, so we need not worry. We can directly take the value, so we'll just say int it is equals to lower bound a dot begin and a dot end and the end value. So we'll just say 80 and 80 and 80. This is not required. Okay, now let's just compile. Cannot convert iterator to int. Okay, it will give us an iterator itself. So let's just get our iterator and we'll say lower bound a dot begin, a dot end, and also the end value. Okay, we have unnecessary brackets here. That's it. Let's run and let's close here. Let's copy our test cases and paste. We got 1, 5 and 1. Why are we getting 1, 5 and 1? Okay, we need to go less than or equal to 30, right? Okay. Next, we are calling the solve function. In it, we are searching for. Okay, we searched for it using the lower bound, and we got our minimum. Now let's just compile. Let's run. Let's copy all these values, paste. We still got 1, 5 and 1. Even y0 is not getting printed. Sorry. Since we have spent 40 minutes on this question, and it's based on a mathematical question instead of our data structures, let's see the answer from a 3-star. Okay, even he also calculated the the elements of 2, and he's going less than all itself, which he's not going to equal to, and he has done it for once. Then for all the test cases he's running this code. Okay, here instead of taking lower bound function, what he has done is he read the n value and he's taking a minimum value and an x, and he took the m. Okay, here value is an where is the value? I guess he defined somewhere value here. It is just VAL. VAL in the sense VL all into LL pair vector. Okay, he took a pointer for value m and value that first minus n. He's taking the absolute value and he's storing in the x, and he's saying mini is equals to min of x comma mini, and he's counting, he's printing the minimum value. So he's taking a function min equal to int of okay, let's do it without looking at the code. Okay, that way we can make sure that we understood the we understood the solution. The main logic is a number is in the form of, so calculate all the 2-set bit numbers and find the nearest one to n. Okay, that is the logic here. Okay, let's write the code by ourselves. So initially he took a many variable, then he took a x value to iterate. Then we are iterating our array with the help of m iterator, and now x is the absolute difference between the our array m dot first. Okay, in minus m, but in array there is no first, right? So how did we solve it? He's saying val auto val dot first, so it is like a, right? So a dot first minus n and min equal to minimum of x comma and mini, and we'll print the mini. I guess I'll get an error saying that a dot first mini was not declared in the scope. Okay, here it should be this way. Sorry, I got confused myself. And this is the pointer. Okay, in vector we don't have first, right? So what was that then if it's not a vector? M is the array. Here you can see M is the array. MIMM. What is MII? It's a map. It's not an array. It has two values, int and int. Okay, it's just the first instance of the value, so it's just we took the vectors instead of map. Though since I said it's a mathematical question, we are using data structures to solve it. And let's take our we have 0, 2 and 1. Yes, it's working. Of course it works correctly. Okay, what did we learn in this question? We learned that we can create all the elements and we can do binary search. Binary search whose time complexity will be less than the order of n. And the other aspect is to find the nearest number, though it is of okay, it is a partially correct answer. We got WA. One is the wrong answer. I guess it should be equal to 32. I mean 30 or 32 bits, right? So let's say 32. I guess the solution in previous question also has 32 there. We will just submit it because all these test cases will of course get submitted. I mean the sample input and output. Let's copy them. Of course we'll get correct answer right here. Currently running test case. Yeah, it's a correct answer. We need to take up to 32 bits. So only there are 2 questions are remaining. Can we solve them now? We have 10 more minutes, that's it. I guess it's enough to read the question what they are asking us to do. So you are given a positive integer n and an array A of size n. There are n lists. Initially li is equals to ai. You can perform the following operations any number of times as long as at least two lists. Select two list li and lj. Append lj to li and remove the list lj. Note that this means lj cannot be chosen in any future operation. Find the number of operations required to obtain a set of lists that satisfy the following conditions. The first element and last element of each list are equal. The first element of the list is the same. Print -1 if not possible to achieve this via any sequence of operations. Okay, we'll be solving this question tomorrow. Since we only have 10 minutes, we'll be not taking it up today. Thank you.